Hi students, for the notes for 11-1, it is called writing equations to represent situations, okay? This is a sort of like a foundation lesson so that you can do the following lessons that are coming up, which is, are on 11-2 and on 11-3, okay? So, one of the things that this section has is determining whether the values are solutions. So first, let's do the fill in the blanks. It says an equation is a mathematical statement that states, there's a word that's missing, that states two expressions are equal, okay? So for example, 2 plus 3 equals 5. This is an equation. We know that this is an equation because it has an equal sign. Equation is a mathematical statement that says two expressions. 2 plus 3 is an expression and 5 is another expression. These two expressions are equal. That's what equation actually means. Okay, so an equation may or may not contain variables. This equation does not contain a variable, but you can have another equation. For example, x plus 3 equals 5. That's an equation and it has a variable. Hopefully you all know that the value of this, the solution of the variable, solution of the equation is 2 because 2 is the value of x that makes the equation true, okay? Which is actually what we are doing today. An equation may or may not contain variables. For an equation that contains a variable, a solution of the equation is a value of the variable that makes the equation true. So for example, if you look at this equation, the solution of this equation is 2. X is 2. So when x is 2, 2 is the solution of this equation. But let's say if I say x is 10, that is not the solution for this equation because 10 plus 3 is 13, it is not 5, okay? So the solution of the equation is the value of the variable that makes the equation true. All right, so with that, let's go ahead and try. Determine whether the given value is a solution of the equation. Sorry, my kids are yelling. Okay, so over here you see it says x plus 9 equals 15. That's the equation. And then it says semicolon, x equals 6. Basically what they want you to do is they want you to substitute 6 for the variable x, solve it here, and see if that is equal to 15, like this. 6 plus 9, and I actually want to see, I'm going to put a question mark, if that is equal to 15. Well, how would I find out? Well, I'll find out if I solve it. 6 plus 15 is 15, which is equal to 15. So yes, x equals 6 is the solution for this equation. Okay. Now, let's take a look at the next one then. So for B, it says y divided by 4 equals 32 when y is 8. Let's see if you substitute 8 for y and solve this side. Is it equal to 32? That's what we want to find out. So substituting 8 for y, I'm going to write 8 divided by 4. Is it equal to 32? Well, let me solve. 8 divided by 4 is 2. And 2 and 32 are not equal. Here's the symbol that represents not equal. Not equal. So, no, it is not a solution. 8 is not a solution for this equation. Let's look at the next one. C. 8x equals 72 when x is 9. We know that 8x means 8 times x. So I'm going to first substitute 8 times 9. And I'm going to see, is that equal to 72? Well, 8 times 9 is 72. So since 72 is equal to 72, yes, 9 is a solution for this equation. So that was, determining whether the given value is a solution of the equation. Okay. All right. Now we can use that in a word problem as well. So the next part is writing equations to represent situations. So not only are you going to tell whether a number is an equation, number is a solution to the equation or not, you are also going to read a problem and write your own equation first, okay? So it says, you can represent some real world situations with an equation. Making a model can help you organize the information and identify what the variable represents. It says, Mark scores 17 points for the home team in a basketball game. His teammates as a group scored P points. Write an equation to represent this situation. And then if you take a look here, this is the home team's points, 46, okay? So then we know that Mark had 17 points. His teammates had P points, and then the total point was 46. So then you can write the equation as 17 plus P equals 46. Mark's points plus the rest of the teammates' points altogether is equal to 46 points. So then that's how you would write your own equation, okay? So, your own equation would be 17 plus P equals 46. And right now, it just says write an equation to represent the situation. If you take a look here, it doesn't ask you to solve anything. So just the equation is the answer. Okay. On the next page, we're going to find out to actually see what is the solution of the equation. Okay. So then let's practice a few problems here where you're writing an equation to represent the situation. Sometimes you have to look at the situation and write the equation. Other times you're simply translating the word problem, okay, the word phrases into an equation, all right? So the very first one, that is exactly what I need to do, just translating. It says, the product of 17 and a number, n, is equal to 102. Well, 17, the product of 17 and a number n. Product means the answer to multiplication. So this means 17 times the variable n. So I'm going to write 17 times n. And then what does it say? Is equal to 102. So the product of 17 and n, 17 times n, is equal to 102. Now, it just says write an equation to represent the situation. It doesn't say solve and tell me what n represents. So we're not doing that. This is the answer. Number 7. Craig is C years old. So C represents Craig's age. Let me just write that, just so that we know. His 12-year-old friend Caitlin is half year younger than Craig. Okay, now take a look here. I'm just gonna translate it, okay? His 12-year-old friend Caitlin, so I'm gonna write 12. His 12-year-old friend Caitlin is, so that's an equation, equals half year younger than Craig. Well, the variable that represents Craig's age is C. So this is C. So I need to write half year younger than Craig. Younger than. Then is a turnaround word. Younger means subtraction. So this is half year younger than C. To write that as an expression, that is C minus 1/2. Remember, younger than is a turnaround word, so you have to turn these around. So C minus 1/2. Let's see if that translation makes sense. 12 is, so 12 equals half year younger than C. Okay, and that's it. That's the equation. Number 8, Kim rented skates for 8 hours. Sorry, I should have enlarged it before too. Kim rented skates for 8 hours. So we don't know how many hours. So 8 hours. H could be 2 hours. H could be 3 hours. The rental fee was $2.50 per hour. And that hour is represented by the letter H. She paid a total of $20. Okay, so it was $2.50 per hour. So $2.50 times the number of hours. $2.50 times the number of hours is equal to, she paid a total of $20. And that is the equation. Okay, next page. We have just a couple more problems here. So now it says writing an equation and checking the solutions. Okay, so you're gonna write the equation and then you will also check what is the correct solution. You can substitute a given value for the variable in a real world equation to check if that value makes sense for the situation. Let's first take a look at the problem. It says, Sarah used a gift card to buy $47 worth of food. She has $18 left on her gift card. Write an equation to represent this situation and use it to determine whether Sarah has $65 or Sarah had $65 or $59 on the gift card before buying food. Okay, so first, we're not going to worry about this part. First, we're going to write an equation to represent the situation. Now, think about the situation. Sarah had a gift card. We don't know how much she had there. She spent $47. She now has $18 left. So hopefully it makes sense to you. Okay, she has some kind of amount on her gift card, and then she's subtracting the amount that she spent, and now that is equal to how much money she has left on the gift card. So like I said, we do not know how much money she had on her gift card. So let's say that's a variable X. Now what we know is she spent $47. So minus 47. And we know that now she has $18 left. So the equation is right here. X, amount that she had on the gift card, minus $47 is equal to $18. So this is the equation, okay, which is right here. X minus 47 equals 18. Okay, now we're gonna do this second part right here. Determine whether Sarah had 65 or 59 on the gift card before buying the food. So that's basically asking you, between 65 and 59, which one is the correct value of X that makes this equation true? So what we need to do is we need to do two math problems in which we're going to substitute 65 and 59 for X and then see which equation is true, okay? So I have the same equation written twice here. So for the first one, I am going to substitute 65 for X. And for the second one, I'm going to substitute 59 for X and see which is true, okay? So this one, I'm going to substitute it here. And this one, I'm gonna substitute it right there. So here we go. 65 minus 47 equals 18. I'm gonna put a question mark here. Or 59, so this one was a 69, now I'm gonna do the 59, or 59 minus 47 equals 18. I'm gonna also put a question mark here. One of those is correct. Well, what is 65 minus 47? Well, 65 minus 47, you need to borrow. 15 minus 7 is 8. 5 minus 4 is 1. Ooh, 18 equals 18. So yes. So I already know that the answer is going to be 65. Okay, well, let's make sure that the other one is incorrect. So I need to do 59 minus 47. And I get 12. And I know that 12 is not equal to 18. So this one's a no. Okay. So once you write the equation, if they give you possible values for the variable, you can plug those in, substitute those, and solve and see which one is the correct solution. Let's do a final one. On Saturday morning, Owen earned $24. By the end of the afternoon, he had earned a total of $62. Write an equation, tell what the variable represents, and then determine whether Owen earned 38 or 31 on Saturday afternoon. Okay, so it says on Saturday morning, Owen earned $24. We don't know how much he earned, but he earned some money, let's say it's M, on Saturday afternoon. So he made, on Saturday morning, he earned 24. On Saturday afternoon, he earned M dollars. And altogether, by the end of the afternoon, he had earned a total of $62. That will be the equation. Saturday morning plus Saturday afternoon, the total is 62. So 24 plus M equals 62. Okay, so I did my first part, which is write the equation. Let's do the second part, which is tell what the variable represents. M represents the amount Owen earned on Saturday afternoon. That's the answer for what the variable represents. Okay, now let's do the last part. Between $38 and $31, when we substitute these numbers for the variable, which one is the solution of the equation? So just like before, I'm going to write the equation twice. So here's the first one, 24 plus m equals 62. Here's the second one, 24 plus m equals 62. For this one, I'm going to substitute m for 38. And for this one, I'm going to substitute m for 31 and c. Okay? So 38 is going to be substituted right here. And then 31 is going to be substituted right here. So let me first write those equations. The first one, 24 plus 38. And I want to see if that is equal to $62. The second one, 24 plus 31. And I want to see if that is equal to $62. I'm going to put a question mark here. Okay, now 24 plus 38 is 62. So 62 is equal to 62. So then, yes, that's correct, which means $38 is the solution. We already know that. We found it out just right now. Okay, but let's check the other one. Well, 24 plus 31 is actually only 55, which is not equal to 62. So no, that is not the right solution. Okay, now let's see if I answered all of the questions that the problem asked. Okay, number one, write an equation. 24 plus m equals 62. Number two, tell what the variable represents. M represents the amount Owen earned on Saturday afternoon. Number three, determine whether he earned 38 or 31 on Saturday afternoon. And by substituting and solving for both, I know that he earned $38 on Saturday afternoon. Okay. All right, that is it.